Welcome to problem 5.1. Those of you who attended the exercise session where we talked about this probably remember that we didn't really tackle this problem that well, so now we're going to make another attempt at doing this properly and firmly, and actually I think I'll show you guys two ways just to make up for the fact that that it wasn't that pretty during the exercise session. Okay, so let's get started. Problem 5.1. So in chapter 5, we're considering compound models. And the basic setup here in this exercise is as such. So we consider claim sizes y1, y2, and so on. And then we assume that the number of claims is modeled by n and that it is geometrically distributed. So let's just write that down. We have the claim sizes, y1, y2, and so on and so on. What do we assume about them? So the yi's are IID, so independent and identically distributed, and they are exponentially distributed with parameter beta, all of them. And what the exercise then tells us is then that means that if we sum the n first yi's, then we get something that is gamma distributed with parameters n and beta. And they say you do not need to prove this. In fact, I think that in chapter 4 or 2, can't remember which of them, anyways, in one of the chapters, I think in chapter 4, we actually prove that the convolution of the gamma distribution is in fact again the gamma distribution or something like that. So we've proven something similar. Now we just use a result that we don't need to prove. So then the sum of the first n yi's, so for I equal 1 up to n, the sum of these is geometrically distributed with parameter n and beta. And note that n is a natural number. A natural number, and that's pretty significant, as we'll notice later on. So what else do we assume? So this was about the claim sizes. Then we also assumed something about the claim numbers. So the number of claims is this geometrically distributed, and what that means is that the point probabilities are given as such. So that means that the point probabilities, so the probability that n is equal to some small n for n ranging from 0, 1, 2, and so on. So all the non-negative integers. Well, that probability is 1 minus p multiplied by p to the nth. So there are actually two versions of the geometric distribution in the book. One version has the parameter p, and the other has a parameter 1 minus p. So sometimes you will see this part to the nth power and sometimes this part to the nth power. But so long as it's clear what is the parameter, then we're all safe. So what we have now is we have the claim sizes, their ID, and added up all together, given that n is equal to some small value n, then we will know that the total claim size is gamma distributed with parameters n and beta. However, the thing is we don't know what the exact value of the claim number n will be, so we write up the total loss as such. So we call the total loss x, and we write it as x being, well, all of the claims summed up together. And since there are n claims, we sum up y1 up to yn. However, n is a stochastic variable itself, so this sum is, well, we don't actually know how many terms are in this sum. That would vary depending on the outcome of n. However, what we do know and assume is, well, we have already assumed that the yi's are independent of each other, but we also assume that each yi is independent of n. So for all I. Equals 1, 2, 3, and so on. So this is then what we have about the total loss. There is one last thing that we need to remember to read, which we sort of forgot during the exercise session, which is why everything went so wrong, and that is this thing here. So always read the entire exercise text. So what we read here is, if n is equal to 0, then x is 0. If n is equal to 0, then x is 0. Actually, another thing that we can establish quite quickly is that n is equal to 0 if and only if x is equal to 0, since if x is different from 0, so if x is greater than 0, then that would mean that, you know, one of the y's need to assume some kind of positive value, and in that case we can't have n claims. So more than 0 claims. So n is equal to 0 if and only if x is equal to 0. And now I guess that we are all ready to go. So we're ready to start solving the exercise. And that will be in the next video.